What's happening? Oh, call your friends to come online. Call them to come online. Oh. Let's start this class. Daniel, how many were you in the last class? Aziza, hey, I don't see them. Oh. Aziza.
Good morning, ma.
Good morning, ma.
How are you?
I'm fine, ma. Where about you, ma?
Good to have you here. Where is your sister, Mary?
I'm trying to reach
Mary
her
is
now,
not here.
ma.
Please tell them to join so that we can start. Okay. Good morning, everyone. Please, let's be muted. Daniel, in the last class you had with Izinobi, how many were you? Unmute and talk.
I'm probably about 15 now. Good morning, ma.
Okay. Okay, well, let's just start. At least, okay, let's give them like 2 minutes. Just so that people can. Adowonyi Esther, please mute yourself. Whenever you enter the class, let's be muted, please. Very important. Okay, like my class, the way my class Olabisi, I dey see you. Ashiru. Okay, normally we are always having classwork at the end of the class. And we take attendance beginning and the end. Attendance is compulsory. And the classwork, you're meant to submit it depending on when we finish the class. If we did not finish all our time, we'll submit it with the remaining hours of our schedule. But if we exhausted our time, then we'll submit it before the end of the day. So, and I advise everyone to make sure they do the classwork themselves. Don't say, oh, let me just copy and submit. No. The essence of the classwork is for you to familiarize with the modus operandi in terms of the question, so that when you enter exam hall, everything will be familiar to you. It will not be strange. Now, the questions are like things you're going to use to revise what was taught each day. So make sure you participate. Okay. Okay, let's go into the class. So in this section, we'll be looking at alicyclic chemistry. I'm going to share this slide at the end of the class. Okay. Alicyclic chemistry is talking about chemistry of organic compound that are in a ring. So we're looking at cycloalkanes. As the name implies, cycloalkanes are those carbon atoms that form a ring. Opposite of cyclo is aliphatic. So we're looking at compounds that are in ring form. They are called cycloalkanes. Follow very well. This course is a very simple course. You can have your A without blinking an eye. So but make sure you're always available in the class. Okay. The structure always show a regular polygon you're used to. Within, just like talking about your propane, cyclopropane, cyclobutane, they are regular polygons. They are polygons you're used to. So we'll be looking at those regular polygons. And remember, instead of methyl, we have methylene, and because the ring is closed. Why methyl is because, so the terminal, all the carbons, there's no terminal, all the carbons are methylene, okay, in a regular nature. So this is an example of cycloalkanes we are talking about. We have cyclobutane, cyclopropane, pentane, and hexane. So the number of carbon atoms is the same. The only thing you're going to put cyclo, indicating they are in ring form. And we also have some of these cycloalkanes that occur in nature. So if you see a compound like chrysanthemic acid, it contains cyclopropane. So some of these cycloalkanes we are talking about is not just something that is useless. It's visible in air, in naturally, at times in our system. Talking about prostaglandins and steroid. Prostaglandin contains cyclopentane, while steroid contains cyclohexane and cyclopentane. So these are things that we can see in nature. So look at some of the structures. You can see prostaglandin. You can see the highlighted section, which is where we have our cyclopentane. You can see chrysanthemic acid. You can see the major structure there is a cyclopropane. So you can see the cortisone, which is a steroid. Now, let me go further. Some of you that normally use Skinel, I don't know why this thing came up. Some of these things are made up of steroids. Some of these steroids, they say steroids are good poison. So if you like Skinel and Format A, and you're always using them, these are supposed to be a controlled drug. If you use them more than 7 days, more than 41 days, and more than 21 days, at the end, the side effect will not bear it. Some people you see they have some skin tags on their faces. You are asking, these are the aftermath of all these steroids. So there are so many steroids, you know. Some of them they are in form of. That's one I saw my sister bought. I was shocked. I said, "This is steroid." Please, whenever you look at something and you look at that is content something sewn, anything that have to do with sewn, cortisone or whatever sewn, they are steroid. If you see them in your cream, run away from it. This cream is going to damage your skin. Aftermath. The aftermath is worse than the benefits, especially ladies. So these are steroids we're talking about. Now, in this slide, we are looking at this cycloalkane. They have properties. We're going to consider properties such as melting point and their boiling point with respect to ring size. Melting points are affected by the shape and the way the crystals are packed. So they don't have uniformity in their ranges. So we cannot say the smaller the ring, the higher the boiling point, because it has to do with pack. Because when crystals are packed together, they are being together, okay, it's going to cause heat to be generated. So making them to start melting even before heat is being applied. So when they're more compact together, their melting point is slower. When they're scattered, their melting point is higher. So if you look at the charts we are seeing, you can realize that the boiling point, it has a regular, the higher the number of size, the higher the melting point. But the higher the boiling point. The melting point does not follow that regular pattern, okay? Because it's not affected by shape, but the way crystals are packed. The pack pattern is what affects that. So in terms of cyclohexane, we cannot say the smaller the size, the smaller the melting point. No, it uses ununiform or irregular pattern. But boiling point follow a regular pattern. Now, naming. Whenever you're talking about cycloalkane, our most interest mainly is about the naming. How do we name these compounds? So naming a cyclo compound, you have to consider the parent chain and check if the parent chain has a greater number of carbon than the substituents. Then you know I'm going to give the parent chain a, okay, when I want to name a compound like cycloalkane, the one that have higher number of carbon becomes the parent chain. The lower one becomes a substituent. Now, if you look at the methyl cyclopentane, you realize that the ring has the higher number of carbon. So that's why the ring becomes the parent compound and methyl becomes the substituent. Then look at this other one. You can realize that my straight chain is having the higher number of carbon, while the ring has the least number. The aliphatic has 4 carbons. So that aliphatic becomes the parent compound. While my ring has 3, my ring becomes substituent. What am I trying to say? Whenever I want to name the cyclocompound, it's not compulsory like that because there is a ring. The ring becomes the parent compound. The parent compound is determined by the side of the chain that has the highest number of carbon. So that becomes the parent. While the other one becomes homoshe. So the parent is one that has a high number of carbon. The one that has the least becomes substituent. So the least can be aliphatic or alkyl, or the least can also be a ring. Now, another rule is that when numbering the carbon of cycloalkane, start with the substituents, the substituted carbon, so that the substituent carbon have the lowest number. When 2 or more different substituents are present, number according to alphabetical order. Let's look at example of what we are saying. Okay, now look at what we are trying to say. Now, I want to name this compound. The first one, how do I look at the same structure having this different name? Remember the normal nomenclature. Whenever you want to name, you have to follow the route that will give the substituent the minimal number. That's what we are trying to say in essence. If I look at this, the compound, I can give it 1, 5, I can give it 1, 3, depending on the route I'm following. So if I follow my clockwise, I'm going to give it 1, 3. If I follow anti-clockwise, I'm going to give it 1, 5. Then the one that has the least number is the correct one, just like you know in normal nomenclature of hydrocarbons. So it also applies here. So whenever I want to name, I have to think of the route that will give me the least number of the substituents on the ring. In that case, remember you can see that the ring has the highest number of carbon. So we're not considering the one that has the highest number of carbon. We are considering the position of this substituent in this part on this particular ring. So that's why we have one is 1, 3, the other one is 1, 5. Because 1, 3 is lower, 1, 5 is higher. 1, 3 is the correct one. This is very, very important because in this particular course, you cannot avoid nomenclature. If you look at the past questions, which I also want to encourage us to make sure you go and get the past question. Go and get the past question. Past question is very important. When you get the past question, practice all those structures there. If you can get like three sets or 2 sets minimum, look at the questions, look at the structures, practice naming them. The essence is that if there is one that you don't understand, look for somebody that can help you, or you come and bring it, to sort it out. So that you don't enter exam hall, a simple question, you just fail it because of carelessness. This is a course you can have 80, you can have 90, just like 213 or 322. But some people will still fail it. At least last time, the least we have was, I think it was like B that we had. But I was expecting all of them to have A. I think maybe one person had C or something. 2 have A, 1 B and 1 C. But this is actually a course you can have A. When I mean A, that when they remove 10 marks, you're still standing bigger. So I wish you the best. So that's the second one. If you look at the second one, we can name it in 3 ways. But what we are looking for is the least lower ones. So I can call 2-ethyl and 1,4-dimethyl. I can also call it 1-ethyl and 2,6. I can also call it 3-ethyl and 1,4. So whenever I say a compound like this, what will I ask myself? I'll have to look at the possibilities. What are the possibilities of this substituent? Which one have the minimal sum? If this one is 2 plus 1, 3, 3 plus 1, 7. This one is 2 plus 6, 8 plus 1, 9. This one is 3 plus 4, 7, 7 plus 1, 8. So meaning that this is a smaller one, okay? So we employ this in naming and nomenclature, meaning that in the exam hall, somebody can say, I got it by talking about 1-ethyl. Another person that say, okay, I want to start by naming with my methyl, the way the compound are arranged. And at the end, I'm going to end up with 3-ethyl. But normally,
Sorry, ma. Good morning, ma.
morning.
Ma, please, the drawings are very small. Please, can you help us zoom it?
Okay, I should help you to expand it. Is it okay like this? Can you see it now?
Yes, we can see it now, but it's a bit small.
Okay, fine. Please, whenever you're not following, I will appreciate that you just stop me. Just unmute yourself and talk. I will hear you, then I'll stop. Okay, look at what I'm saying. This is 1,3-dimethyl. Now, if I want to name this structure, I will follow the route that make sure that the sum of the substituent, we have 2-methyl. So if I go my clockwise, I'm having 1 and 3. But if I go my anti-clockwise, I'm having 1 and 5. So 1 and 5 is higher than 1 and 3. So I choose 1 and 5. In the exam, you can see somebody still using 1 and 5. So that's why I said the minimum sum of the substituents is the correct nomenclature. Now look at this one. If you look at this structure, you realize that I can as well decide that I want to name this the way the substituents are arranged. So I'll start with methyl and end with methyl. So I'll have 1, 3, and 4. Okay, which is this structure 1, 3, and 4. If I calculate the sum, 3 plus 4 is 7, plus 1, 8, which is high. But if I start this way, I have 1, 2, and 4. 1, 2, and 4 is 6, plus 1, 7. This is lower. And if somebody says, I want to start with ethyl, because I feel that ethyl is E than M, then I'm going to have this structure saying 1-ethyl, 2, 6, making the sum to be 9. So whenever I'm giving a structure like this, don't look at the alphabetical order is not by virtue of arrangement. Don't talk about arrangement or alphabetical order when you're trying to number the substituents in order to get the how they're going to be arranged on the ring. No, alphabetical order is when you're naming them. So don't allow alphabetical order to affect your decision in numbering these substituents the way they're going to be aligned on the ring. Do you understand what I'm saying? If you understand, somebody should mute and confirm. And if you don't understand, let's go back because it's very important. Should
Yes,
I continue?
ma'am. Yes.
I should continue.
Yes, ma'am. Yes.
All right. Okay. So that's what we are trying to say here. So whenever you're naming, consider the substituents that have the least number and give them priority. Okay. Now, whenever we are not naming compound, just like in your aliphatic or hydrocarbons, that when I have halogen substituents, they are treated the way they're treated in your hydrocarbon. If I have fluorine, it's going to be called fluoro, chlorine, chloro, and others, as you know. Each of our substituents did not change here. So when the name of substituents is still the same name of substituent, the way you know it in your hydrocarbon. So let's look at these examples now. So look at this compound. If you look at the ring has 4 carbons, making it butane. Because it's in a ring, it becomes cyclobutane. So cyclobutane is a parent compound. And we have substituents, which is bromo and methyl. Okay. Now, if I want to start, because I can do 1, I can do 2, because both of them are the same thing. So in this case, I can start with bromo, because even if I do 1 bromo or 1 methyl, they are still the same thing. The sum is still the same thing. 1 and 2 is the same thing. Okay. But because bromine now comes lower in the in alphabetical order, I will do 1 bromo and 2 methyl. Remember, because there is no change in their sum. So that's why I'm doing that. But if there is change, I will not think about alphabetical order. I hope you understand that. So look at this one now. If I look at this, I have 1 bromo, 3 ethyl, 5 methyl cyclohexane. Now, because what I'm doing is that anywhere I follow, bromine is on carbon number 1. So however I follow, I'm still going to get the same thing because bromine is 1. Either I have 1 and 3 or 1 and this other one is 3, this one is 3. So 1, 3, 5 that's the highest I can get. So there's no how I can do it. So if I go the other route and say I want to start with ethyl, it will not make any sense. Since my bromine is carbon number 1, I have to continue with carbon number 1. Let me go back to the other one that we did. If you look at this carbon, we cannot say there's any carbon number 1 because the place that's supposed to be position number 1 is the place we have 3. So there is nothing there. So there's nothing like carbon number 1. Unlike this, the first one, we have methyl to be on position 1. So whenever you have a compound that is on carbon number 1 and the other substituent, when you have a substituent on carbon number 1 and the other substituent does not influence the sum, then consider alphabetical order. But if there is an influence in the sum, neglect alphabetical order and make sure you maintain the sum. So look at this other one. Now, if you look at this, you realize that my ring has 4 and my aliphatic, that my alkyl has 3 because it is, well, I say it's 3 because it's substituted. So that one is 1 methylpropyl. So because my ring has 4, my ring still becomes the parent compound. So I have 1 methylpropyl as a substituent, then have cyclobutane. Or this 1 methylpropyl can also be called secondary butyl because it is butyl, but it's in secondary. So we can call it, so anyone, but make sure that you cannot say, they are equal. They are not equal. Because assuming I'm having butyl, normal butyl, I will say they are equal, but they are not equal. This one is secondary butyl, which is not normal butyl. So we have 1 methylpropyl cyclobutane or secondary butyl cyclobutane. So anyone that you're used to, just be consistent with that. Okay, this is another naming. Like I said, chlorine is on carbon number 1. So we cannot just say we go for E where YC is number 1. So just follow the movement and go clockwise and get a 1 chloro, 3 ethyl, 2 methyl cyclopentane. Another thing I want to stress on this naming is that remember the modus operandi when you're naming your hydrocarbon. So make sure you maintain the issue of number and number, comma, number and letter hyphen. At this level, you will not be pardoned for such mistakes of writing 2 without putting hyphen and you want to put bromine. Or you want to put 1, you do not put comma, you will not be pardoned. So make sure that whenever you're writing, you obey all the rules of nomenclature of hydrocarbon that you know. Okay? All right. Any questions so far?
No, ma.
No question. I know it's a very simple one. Okay. Now, this is what they call spiral compounds. I would have loved us to have a classwork that we're going to write here. But let's look at these spiral compounds. Now, this spiral compound is another type of alicyclic compound. So how do we name them? If you look at this structure, you're going to write it, spiral is like S. So you're going to follow a pattern that will create your S. So that's why we're starting with that methyl. So 2-methyl, because double bond is a functional group, which we are going to consider whenever we are naming. So whenever you have a functional group, consider the functional group and give it priority. So we're starting with carbon that bears the double bond. So we'll move to creating an S sign. So we have 1, 2, 3, 4, 5, 6, 7, 8. It is named showing the S sign. Now, carbon number 2 is where we have our substituent methyl, and the double bond is on carbon number 1, and the total number of the carbon is 8, making it oct. And the bridge that connects the first ring with the second ring is 3 and 4. So that's why we have 2-methyl spiro 3.4 oct 1-ene. 2-methyl spiro 3.4 oct 1-ene. So whenever you're given a spiro compound which is composite is going to come out, look at the substituents. What are the position of the substituents? Look at the functional group. What are the functional group involved? When you consider this, then just start numbering to maintain the S sign and putting the functional group accordingly. Then consider the point of linkage where ring A connects to ring B. So that is what will be in the brackets. And the bracket is not circle bracket, it's square bracket. A second example is this. If you look at this compound, like I say, you're creating an S sign, okay? Now, bromine is on the first carbon, and that is the substituent we have. So we number all the way, and we have 10 carbon, making it decaying. This compound does not have any double bond. So that's why it's fully saturated compound. And my substituent is on position 1 and position 8. Why position 1 is bromo, that's bromine. Position 8 is methyl. The bridge, the connecting bridge is position 4 and 5. So that's why we have 1 bromo hyphen 1 hyphen bromo hyphen 8 hyphen methyl spiro. Another thing you should know that everything is one word. There is no space. Until just like the way you name your hydrocarbon, you don't give any space. The only thing, either you're putting hyphen or you're putting comma, or you're putting brackets. Everything is one word. So we have 1 bromo, 8 methyl spiro decane. So let's look at it again and ask question on this spiro compound. I want us to ask question on this spiro compound. Let's ask question
I'm sorry,
now.
the 4.5, what was the minimum?
The 4.5 is like the bridge that connects ring A with the ring B, connecting point. And that where in this place we have 3 and 4. Why here we have 4 and 4? So it's a connecting point, just like a bridge that connects the first ring with the second ring. Understood?
Yes, ma'am.
So another question, please. Let's ask question on this spiro compound because some people still make mistake on spiro compounds. Any other question? Daniel, have you taken attendance?
Yes, ma'am.
Okay, thank you. So if there's now, today we're going to do, because this is the first day of the class. Nena, I cite you. This is the first day of the class. So next class, please. Next class, please. I want us to be available on time so that we can optimize our time and do our classwork and submit before the end of the class. Okay? So now you're going to bring your paper out. We're going to do classwork. You're submitting immediately before our time elapses. So before then, if you have any question on the nomenclature, ask now before I bring the classwork. The floor is open for any question. Don't be shy in asking questions. Now your school fees. Nobody will beat you. You're asking because you don't understand and you're meant to understand. So ask your question. So no question, right? Very well. So now this is your classwork. Though the classwork is not complete. In the next class, I'm going to give us classwork on spiral compound. So these assignments which you're going to do now, the nomenclature of this compound. As soon as it's 12, as soon as it's 12, uh, Daniel, can you give me a screenshot of this? Screenshot it and share it for me to create
I'm sorry,
the
ma. If
assignment.
you can reduce the size of the screen, I can't screenshot.
Is it okay now?
Yes, ma'am.
Okay, fine. Screenshot and share so I can create the assignment on the Google Classroom. Please start your time. I've started. Start giving me the nomenclature. Just draw the A, give us the name, B, C, D, E, and F. Just do that. It's a very simple one. You can deal with it. With what we've learned, you should be able to handle it. Let me go and create your Google Classroom so that nobody will tell me that I did not submit on time because the classroom was not available on time. I have to give him a start now. How can I not save the name? Yeah, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16, 2, 6, 8, 2, 5, 6, 8, 2, 12. Two marks is 12. Assignment 1. My one, good morning. Okay, I think I've updated the classwork on the Google Classroom. So do and submit. I think we can log out of the class. I'll see you next on Wednesday. Let's endeavor to available on time, and I'm going to share the slide with you too on the page, so you can have time to go through it.